Hello, we are looking at section 3.2, which is polynomial functions, and then we will discuss how to graph these functions. A polynomial of degree n is a function which looks like this. So these are a bunch of terms added together or subtracted depending on the sign of these a's. So a term is something that is separated by a positive sign or a negative sign. So for example, here are some polynomials given. So this is negative 5x. So this is one term. Then this is the second term. Actually, the sign of the term goes with the term. So this, you can think of it as a negative 5x. But basically, the negative sign is with the term. Plus 2x squared plus 3x cubed plus 7x. So, and then here we have a polynomial in t. Note here. Now the variable I have changed. So it can be any variable, any letter. But normally we use x and t. And so what are these a's? A sub n, a sub n minus 1, and so on. These are called coefficients of the polynomial, basically coefficient of each term. So this a sub 0 is a coefficient of the term with the variable x to the n. A n minus 1 is the coefficient of x to the n minus 1, and so on. So when we are coming here, a sub 2 is the coefficient of x squared, a sub 1 is the coefficient of x, and this a sub 0, this we don't have any x here, so we call it a constant coefficient or constant term. Okay, so that's what it is called. And why we call it the polynomial of degree n? Well, the highest term or highest variable power here is n. That's why it's called polynomial of degree n. So the degree of a polynomial is found by looking at the highest power on the variable. So in order for this expression, which is given here, this has to be a polynomial of degree n, we must have this condition that a sub n is not equal to 0. So that a sub n, the nth coefficient, should not be 0, because if that is 0, then this term will be gone. So if this term is gone, then this is no more a polynomial of degree n, this is a polynomial of degree 1 less than n. So an minus 1, if the condition that a sub n minus 1 is not 0, and so on. So that's what these are polynomials. And now the first, not the first term always, but the leading term is the term that is called that has the highest power on the variable, that is called the leading term. And the coefficient of that leading term is called the leading coefficient. There are other polynomials as well. So we generally don't say the whole word polynomial of degree n, we just say polynomial. So we refer to them as just polynomials, but basically they are polynomial functions of degree depending on the highest power on the variable. So for example, here we have, this is the first term is negative 5x, but that is not giving us the degree of the polynomial. The degree will be, we will have to find what term is the has the highest power on the variable, which is, I believe, this one, 3x cubed. So 3 is the degree of the polynomial. So this has degree 3. And the leading term will be, so sometimes it's a lead term, that is 3x squared, and lead coefficient is 3. In the same way, now you can look at the second polynomial here, and we see that this is arranged. So this is called descending order, descending order of a polynomial. Sometimes we write it in ascending order. Ascending order means increasing powers of the polynomial. Descending means decreasing power of the polynomial. So the leading term or lead term is this term, and the lead coefficient is negative 1/2, and the degree is 6. Okay. So we call that these functions y is equal to x square, y is equal to x cube, these f of x, we can say f of x is equal to x squared, f of x is equal to x cube, and so on. These are functions whose graph we have seen. So x square is a parabola, x cube will be a graph like going like that. So we have already seen these graphs, and we can use them to graph functions of these kinds, which are basically just transformations of these functions. These we call them power functions. So these are also polynomials, but they have only one term, and a polynomial of one term is called a monomial. A polynomial with two terms we'll call a binomial, and then three trinomial, and then we get lost of names. So then we start saying polynomial with four terms, polynomial with five terms, and so on. So only monomial, binomial, and trinomial, these are the words. Yes. Okay, so here are the graphs of these translated or transformed functions. So first x cube. So we know the x cube graph looks like this, the blue dashed line here, the first A figure. And if you negative x cube means flip it about the y-axis. Well, if you notice, this is the same as, this basically means flip about the x-axis. This is flip about the x-axis, but notice here, this is the same thing as negative of x whole cube, which means flip about the y-axis. So if you notice, this is symmetric about both, like we can say it's symmetric about the origin, or a twofold, like first you fold it about the x-axis and then fold about the y-axis, or vice versa, first about the y and then about the x, and then the graph will fit. But if you fold only about one axis, the graph won't fit on top of each other. So this is called symmetric about the origin. So this graph, whether we do flip about the x-axis or the flip about the y-axis, we are getting the same result. But so this is the flip, and then we are getting this red graph here. We're now looking at the second one, which is negative x minus 2 whole raised to the power 4. So the base function is x to the 4, and this is translated to the right 2 units. So this is what the red graph is showing, the translation. And now the last one, which is negative x to the 5 plus 4. Now negative x to the 5 will look similar to what we saw in this figure A. The graph of x to the 5 will look very similar to x cubed, only that this will be a little bit more flatter at where it bends. So this one, sorry, the last one here, negative 2x to the 5 plus 4. So we have negative x to the 5, which will look very similar to this negative x cube, but now we have to raise it 4 units up. This is what the graph looks like. So these are translations, but note here that the graph of x square and the graph of x to the 4 look kind of similar. So they're both going up here, and the graph of x cube and x to the 5 look like this, going up here, going down here, going down here. And so we will come to this in a minute. So notice that the graphs of a polynomial is always continuous. Polynomial is just considered a continuous function. This means that the graph has no breaks or holes. Moreover, if the graph of a polynomial function is a smooth curve, so we say it's a smooth curve, like smoothly flowing curve. That is, it has no corner or sharp points or cusps. What are cusps? So something like this, where you get something. If you ever noticed a pipe, the water pipe in your lawn, sometimes if it stays out for a long time, the heat, it does this. So the water gets kind of stuck and doesn't flow out. So this is called a cusp. And so we don't have cusp, we don't have corners, and then we don't have asymptotes. If you recall, an asymptote would break the graph. For example, the 1 over x square has something like this. So this is asymptote vertical, so it doesn't have vertical asymptotes, it doesn't have horizontal asymptotes. So it goes on and on and on. the Okay, so now here are some figures. So first one here, you see there is a break, there is a hole here. So these cannot be a graph of a polynomial. Similarly, in the second picture, we have a corner, like a pointy kind of a place, and then we have a cusp. Okay? And so these cannot be graphs of polynomials. They should be something like this, So going on, and they can go up and down, up and down, up and down, but they keep going. So when we graph a polynomial function, first thing we have to important thing we have to know is what is the end behavior. So how do you describe the end behavior? So this is how I have shown you. These are two ways to describe the end behavior. One way, or there is a third way that you write it in words. So it's your choice. But this is one way you can show it by making a little small, axes, and then just putting arrows going like this. And note here, these are a little bit curved arrow, not like straight arrows like this, because the polynomials don't go like that, they are curved. So if n is odd, means the degree is odd, and then your lead coefficient is greater than 0, then it will behave like x cubed, which goes up here and goes down there. Okay. So basically what we mean to say here is, if I take a big X value, so for example, simple X cubed graph, if you give it a big X value, for example, let X equal to 10,000. So then Y will become, can you see, imagine 10,000 cubed. So it will be a huge big number. Okay. Even with 100, if your X is 100, the Y will become, so there will be 6 zeros, 1 million. So already you see how big this is. And then if you, so notice here, when you have a positive value for X, we are getting a positive value for Y. So we can say it like this, written here in red, that Y goes to infinity plus infinity as X goes to plus infinity, means as X becomes bigger and bigger, Y becomes bigger and bigger in the positive direction. Now we also want to know what happens when X becomes smaller and smaller, or you can say bigger and bigger in the negative direction. So which means X is going in this way. So then if you plug in X is equal to minus 100, you'll notice that it gives you Y is equal to minus 1 million. So if you give it the value X is equal to negative 100, you'll end up getting the Y is equal to negative 1 million. So that's how we describe this by this arrow, or writing that Y goes to negative infinity as X goes to negative infinity. Now if n is still odd, but if we have the leading coefficient is negative, like the one we saw in a previous example here. See, we had negative X to the third. So what happened? Our graph is going like this, the red one, down here, up here. So that's how it will, so in other words, it will behave like opposite to what we have when A is positive. So we have the lead behavior shown here, like it's when X goes to Y is going to negative infinity when X goes to positive infinity, and then Y goes to positive infinity when X goes to negative infinity. In the next one, we have that n is even. So n is even, then it will behave like a parabola. So when a is greater than 0, the leading coefficient is greater than 0 on both sides, the graph will be going up. And if a is less than 0, the lead coefficient is negative, then on both sides the graph will keep going down, down, down. So you can see as in with infinity I have written there. So for example, what is the end behavior of each of these polynomials? So first we trace out what is the lead term. So here is the lead term. We see that the degree is 3 and the lead coefficient is 3. So it means it will behave like the x cube graph. So we have 3x. This one is lead behavior like this, or you can write y goes to infinity as x goes to infinity and y goes to negative infinity as x goes to negative infinity. With the second one here, we have the lead term is this one, so degree is 6, even degree, and then coefficient is negative, so it will go down, down, down on both sides like this picture I have here, or y goes to negative infinity as x goes to positive infinity and y goes to negative infinity, as x goes to negative infinity. So x goes to positive or negative, y goes to negative in both cases. Okay, so the next thing we will need to graph a polynomial is the zeros of a polynomial. So what is the zero of a polynomial? It is basically what is when it is going to cross the x-axis, or what makes the equation p of x is equal to 0, what the values that make x 0. The values of x that make this equation 0. So we say, so these things are equivalent, so we can use one expression for another. For example, c is a 0 of p is the same as saying that x is equal to c is a solution of the equation px is equal to 0. Or we can say x minus c is a factor of p of x, or c is the x-intercept of the graph. So what is a 0? It is basically the x-intercept of the graph, and which can also be called a solution of the equation p of x is equal to 0, or we can say x minus c is a factor of p of x. Because remember, if you have a function, let's say x squared minus bx plus 2, so we factor it, we can write it as x minus 2 times x minus 1. And now if we set it equal to 0, we can now figure out that x minus 2 is 0 or x minus 1 is 0. So it gives me x is equal to 2, x is equal to 1. So notice here, so when we say x is equal to 2 is a 0 of the polynomial, if this is a polynomial, so because remember x is equal to 2 is a solution of this equation when we set it equal to 0, the solution of that equation. Or otherwise, if we don't put it equal to 0 and we keep our p of x, and we end up getting factored in the form this, then x is equal to 2 and x is equal to 1 will make the polynomial 0. So those are the solutions of this equation. And we can also say now, because remember in factored form that expression looked like x minus 2 times x minus 1, which means x minus 2 is a factor of the polynomial and x minus 1 is also a factor of the polynomial. So the next is the intermediate value theorem for polynomials. Now this is the theorem. We will only look at its statement and then look at what it means. We will not look at the proof of the theorem. So it says if a p is a polynomial function and p of a and p of b have opposite signs. What do we mean by p of a? The value of the function at x is equal to a. P of b, the value of the function at x is equal to p. Okay, so let's look at this one. P of a and P of b have different signs. So let's say P of a, the value of the function at a is here, and this is b is here. So the value of the function at b has opposite signs to it, has to be negative, because P of A is positive. So P of A is over here and P of B is down here somewhere. So in order to come from top to from this point to this point, the graph has to cross the x-axis somewhere. So where will it cross it? It will cross at C. So it will be something like this, and then it can go wherever, but it has to cross it at C. So that's what the theorem is saying. That if we have this situation, so this gives us a kind of a method or a quick way of seeing where where the zero is and how the function is behaving around that zero. So also then we can get something. Okay, let's see now if we have the opposite. At A the value is negative and at B the value is positive. Somewhere have the value at B. So f of P of B is here and P of A is down here. Still now in order for the graph to go from this point to the point up there, let me call it A and this B, to go from point A to point B, it has to cross this x-axis and it will cross it at the zero of the polynomial. And also what we see from here is that if there is another zero, for example, let's say somewhere then it has to come down to cross it. So if you notice between two successive zeros, the graph can either be above x-axis or below x-axis. So it cannot be, because if it is below here, then it has to cross again. So we miss that zero. So which means we have to go back and check our work. Okay. The last thing before we start to see how to graph, multiplicity of a zero. So what is a multiplicity of a zero? Sometimes you might notice a new factor. So for example, if you have x cubed minus 4x squared plus, so what I want, 3x minus, let's say 12 no, let's see, 3x squared minus plus 12x minus, okay, so let me see that. So we have x to the third minus 3x squared plus x squared. What am I wanting here? Okay, let's see, x minus 1. Let's see what happens. So we x plus 1, sorry. We get x times x squared, we can factor out x minus 3. Okay, this is not working. Okay, maybe we'll come later to this. But anyhow, so what it means is that if there is a factor that is appearing more than once, so for example, if you have p of x equals x minus 3 times x minus 3 times x minus 3 times x minus 2 times x squared. So you see the x minus 3 is appearing thrice, so we can actually write it as x minus whole cubed x squared times x minus 2. So this is appearing 3 times, this is appearing twice. So this power, however many times they are appearing, is called the multiplicity of the zero, of that zero. So we can say the multiplicity of the 0, 3, which we'll get from here, is 3. And the multiplicity of x, the 0, which is 0, has the value 0, will be 2. So the multiplicity of zeros depends on how many times the factor has appeared. For example, in this example over here, if we have this polynomial, so the zeros of the polynomial are x is equal to 0 from here, x is equal to 1 from here, x is equal to negative 1 from here. So now, okay, I didn't need this line here. Okay, so the zeros, what are the zeros there? 0, 1, negative 1. What is the multiplicity? The multiplicity of 0 is 1 because x is appearing only one time. So the multiplicity of 1 is 3 and the multiplicity of negative 1 is 2. And the degree of another thing, yeah, in this case, this is already given in factored form. How will you figure out what is the degree of the polynomial and what is the lead coefficient? So the degree here will be equal to, what you will do is you take the highest power of each and add it. So if you see, if you expand this one, the first term or the highest term with the highest power or exponent will be x square, x cube, sorry. And when you expand this, it will be x square. So you multiply these or add the power. So basically, it will be the degree can be obtained from this. The degree of x plus degree of x cube plus degree of x square. So basically, don't write this. You just say degree will be equal to 1 plus 3 plus 2, which is equal to 6. That's how you get the degree. Now, what about the lead coefficient? That will be the number that is appearing in front of x. So if we had a number here, we will worry about that. But in this case, that number is 1. Then we will raise it to the power. So 1 square is just 1. From here also 1 square is 1. And from here 1 just 1. So multiply them, we get 1. So in this case, the lead coefficient or the lead term will be 1 into x to the 6. And because remember that tells you the end behavior, so we need that. Okay, so let's see how to sketch this. Well, before steps for graphing polynomial function. Okay, let me do this in the next video.